A particle is moving along the curve y is equal to x squared minus 6x plus 9 if its velocity along x-axis is v sub x is equal to 3 meters per second. If express its position in vector notation. Okay. So we have the equation y is equal to x squared minus 6x plus 9, where x represents the distance. So we have the given the velocity is equal to 3 meters per second, and we know that the velocity is also equal to the derivative of the distance with respect to time t. So we just have to substitute v sub x into this formula, which is 3 is equal to dx over dt. So we have 3 dt is equal to dx, and we have to integrate this, getting 3t is equal to x. So substituting, we have t is equal to 4 seconds. We have 3 times 4. So we just have to substitute x into the equation x squared minus 6x plus 9 to get the value of y. So we have 12 squared minus 6 times 12 plus 9, getting the final answer of 1 meter. So we're gonna change it into a vector notation, which is xi plus yj. And just substitute the x and y values, which is 12i plus 1j, or simply s is equal to 12i plus j.
The velocity of a particle is v is equal to 2i plus 5 minus tj in terms of meter per second, where t is in second. If r is 0, when t is 0, determine the displacement of the particle during the time interval t is equal to 1 second and 2 seconds. So, we're using the formula solution. We're using the formula dr is equal to v dt. dr is equal to 2 plus 5 minus t j dt. So let's integrate both sides. R is equal to 2 ti plus 5 t minus 1/2 t squared j in terms of meters. So when time 1 is equal to 1 second and time t sub 2 is equal to 2 seconds. So we direct substitute this time to this equation. So we have r t sub 1 is equal to 2t I plus 5t minus 1/2 t squared j. So we have to substitute the t sub 1 to this equation. So r 1 second is equal to 2 times 1i plus 5 times 1 minus 1/2 1 squared j. So we have 2i plus 8 plus 9.5 J in terms of meter per second. And so I will correct this in terms of meter. And R T sub 2 is equal to T I plus 5T minus 1 half T squared J. So it's just the same from the first equation. We need to substitute the T sub 2 from this equation. R sub 2 seconds is equal to 2 times 2 I plus 5 times 2 minus 1 half 2 squared J. So we have R sub 2 second is equal to 4I plus 8J in terms of meters. So we have the formula of delta R is equal to R sub T sub 1 minus R sub T sub 2 rather R minus T sub R sub T sub 1 to calculate the interval of T1 and T2. So we have R2 4I plus 8J minus the R sub 1 2I plus 9 halves J then we have to minus I and J to J. Delta R is equal to 2I plus 3.5 J in terms of meters. So we have the final answer.